Welcome back, everybody. So today's discussion is the 1903 Nobel Prize in Physics, which was split between three people. It is split between Antoine Becquerel, Pierre, and Marie Curie. First husband and wife team to ever win the prize. I'm going to get to more of that in a minute, but because the Curie family was simply amazing, and I think it was, in fact, I'm certain it was all because of Marie Curie. Pierre had his contributions, but these two, while both Nobel laureate level scientists, one of them was head and shoulders above the other. But this particular prize was a shared prize, and between these two, half of it went to Antoine because he was the first to discover spontaneous radiation. Um, he got excited after Röntgen's work on X-rays, and he was looking at phosphorescent materials, and he was using different methods to do that. We'll get to that in a minute. But he was the first one to discover it. Um, and Pierre and Marie Curie kind of formalized it. They were the ones that explained it. So let's dive right in. So he got half the prize for the discovery, and they split half the prize for the explanation. By the way, that's a actual picture from Marie Curie's lab notebook, which is still radioactive to this day because she kept radioactive samples on her desk, and it irradiated everything around it, including the lab notebook and her and all kinds of other stuff. So um, let's dive in. Antoine, he essentially he discovered spontaneous radioactivity, but he discovered it accidentally. But one of the things about some of these larger scientific discoveries is lots of people can see something unusual and go, well, that's weird, and they just move on with their life. He was smart enough and well trained enough and relentless enough to look at it and go, that's weird. I need to go figure this out a little bit more. But he discovered it because he got excited after the discovery of X-rays, which was the 1901 Nobel Prize. Um, and he was looking at different fluorescent materials, and he said, okay, well, maybe, yeah, you can generate these X-rays. Maybe there's a material that generates these X-rays as well. So he was looking at fluorescent materials, and putting things, on photographic plates with coins and other metals in the way. And eventually he tried uranium salt. Bingo bango, he discovers spontaneous radioactivity. But he was like, huh, weird. And it was different from X-rays because of the way it penetrated certain materials. It was just, he knew it was different, but he had no real explanation for it. So published the paper, discovered it. That's Nobel laureate worthy because radioactivity spontaneously coming from the nucleus of an atom was absolutely unknown before that point, but now it's known. Well, along come these two, who very shortly after that saw that discovery and went, okay, we're on it. Now, before we get to what all of what they did, I want to point out a couple things about Marie Curie. Pierre, let's cover him first. He was an expert in crystallography, magnetism, piezoelectricity, radioactivity. Radioactivity came after this, obviously, but he had those other three. So he was a good experimentalist. He was world class. He was certainly Nobel laureate level, and so was she. But she was the first woman to win the prize. She was also the first person, male or female, to win the prize twice. She won it, and she actually coined the term radioactivity. She won the physics prize in 1903, the chemistry prize in 1911, so not that far apart. The family, because of her driving force, won 5 Nobel Prizes over time, and she was the first woman to be a professor at the University of Paris. She was a force of scientific nature, one of the most brilliant people to walk the planet by any stretch of the imagination. And had her life not ended a little bit earlier than it should have, she probably would have gone on to contribute more and more and more. These two uh, jointly just explained um, the radioactive, spontaneous radioactivity. So what happens in radioactivity? They formalize the whole thing. Is you have a large nucleus of an atom, uranium, californium, a lot of bigger ones do this, and because it's so large, it's not stable. Smaller nuclei are very, very stable. Larger ones tend to not be. So when you hear a nuclear, radioactive, whatever, that's not X-rays. If you remember the video from the 1901 Nobel Prize, those are generated in the electron cloud. These are things that are generated from the nucleus, way down deep inside the atom. And this form of radioactivity is what happens when the nucleus falls apart. So you either get gamma radiation, you get a particle, you get a different two smaller atoms, you get all sorts of things that come out. But the point is that when that radiation comes out in the form of gamma rays or neutron radiation, alpha radiation, that tends to be much more dangerous than X-rays. So if you're around it for a long period of time in large quantity, it will kill you. It just will. And Marie Curie, she passed away because she kept a jar of it on her desk forever because that's what gave her notoriety. Her husband was actually killed in a traffic accident in 1911. So his life was ended early. Her life was ended earlier than it should have been. But they did have kids, and those kids went on, and the family went on to do great things. But um, what they did was they formalized this understanding to a certain extent. Um, but they were the first ones to kind of really start to say, okay, here's what's going on. There was a lot of further formalization that went on later, and we'll get to that in other prizes. But they really kicked off this nuclear era by saying, hey, look, that thing that other guy saw, it's actually coming from the nucleus. It's not coming from the electron cloud. And what we're winding up with after that is different elements. So when uranium decays, for instance, or americium or California, or any of them decay, what you wind up with is different decay products on the other end. So you don't have uranium anymore. You have something else, right? Because the nucleus lost pieces and now it's no longer got the right number of protons and neutrons to be declared uranium. It's got something else. But the thing is, the resulting particles are smaller and way less than the original ones. So when uranium goes through this process, or any of the radioactives go through this process, the resulting products have slightly less mass, and that is turned into energy by E equals mc squared, which was explained later by a certain physicist named Einstein. So a lot more to come here, but these two were the first to kind of start to explain it, which I think makes it interesting. But Marie Curie, we have not heard the last of her. That woman was all over in the scientific community and was just incredible. Um, Not enough good things can be said about her. And I think, if anybody ever wants to do a documentary or a biopic or a life of, she's the one to do it about, man. She was great. The But anyway, that's radioactivity. It looks great in a diagram. It all sounds nice and good. And then you see it. This is what it looks like inside a reactor. This is large quantities of radioactive material. This is not small little nuggets. This is big ones. It's in a research reactor. So it's actually a small reactor, but that's larger than you want to have at home, obviously. But what do you do with radioactivity besides kill people? Well, medical uses X-rays, right? So that's coming from the electron cloud. That's not nuclear. That's different. You have radiation therapy, CAT scans, CT scans, chemotherapy. All those medical uses came out of the no understanding this stuff. There's a bunch of industrial uses, including removing pollutants from coal-fired power stations, non-stick cookware treatments to get the non-stick stuff to work, smoke detectors in your house. Don't worry, the smoke detectors in your house have such a small dose of radiation, nobody cares, but that's what makes them work. And nuclear power plants, you can generate enormous amounts of electricity from a very small little area. And treated properly, even the radioactive waste can be handled. So I understand there are some accidents with them, but there's accidents with coal plants, and there's accidents with other stuff. And the Navy has put mobile nuclear power plants on ships for decades, and they're doing fine. Yes, I understand there were some accidents back in the 50s, and maybe I think there was one of the Russians had in the 60s, but yeah, it's much different than it was in the mid 1900s. So that's the 1903 prize. Was these three and the discovery of radioactivity, which does impact your life every single day. It does get a bad rap because of things like Chernobyl, but done properly and done safely, technology's come a long way since the last major accident, which was Chernobyl in 1980s, right? So it's now 2024, so 40 years later, we've figured out some of the safety stuff. But remember, this was still only 1903, so this is a little over 120 years ago when the prize was awarded for this. So it's maybe 130 years ago when the work was done. But we've only had 130 years of understanding this stuff, and the last major accident was Chernobyl, which was 40 years ago. There was Fukushima, but Fukushima was actually pretty well handled by comparison to like Chernobyl. But if you look at the accidents, there's not very many of them, and even the Fukushima reactor was a very old design that wasn't maintained properly. So if you look at nuclear power in general, it's relatively safe stuff. It's as safe as anything else that's out there. So it is what it is, as they say. But this is the prize, and this woman right here is one of the pioneers of the nuclear world. She's amazing, and we'll get to more of her in the 1911 prize in chemistry. So she actually was the first person ever to win two prizes, and they weren't both in physics. One was in physics, one was in chemistry. So she kind of had the mastery of two completely different fields. She was really a phenomenal person. Everybody have a great day. I hope you enjoy this series. Click like, subscribe, or follow wherever you see me, and we'll see you on the next one.